In this video, we're going to write a balanced chemical equation for the reaction between aqueous solutions of calcium chloride and potassium phosphate that produces precipitated calcium phosphate and still dissolved potassium chloride. So to start with, we need to figure out which are our reactants and which are our products. We can figure out the reactants because we're looking for the reaction between calcium chloride and potassium phosphate. So our reactants are calcium chloride, which is CaCl2, because calcium is always a 2+ ion and chloride is always a 1-. And then potassium phosphate, K3PO4, because phosphate is always a -3 anion and potassium is always a +1 cation. Now, as for their indicators of state, aqueous solutions. So these are both aqueous. Now our products, which we can tell because they are produced, we've got the calcium phosphate, which is Ca3 with 2 phosphate ions, and that's because of charge balancing. And our other product is the potassium chloride, KCl. Now as for state, it says that the calcium phosphate precipitates, which means that it's a solid. Solids precipitate out of solution, and then still dissolve potassium chloride. So our KCl is still aqueous. So now we have these indicators of state, we have our products, we have our reactants. Let's construct our initial equation. And I'm going to leave out the indicators of state until the very end just to make it a little clearer. So we've got CaCl2 and K3PO4. with our arrow pointing to products, Ca3PO42 plus KCl. Now it's going to be easiest for us to treat the phosphate as if it is just one unit, like we would the chloride or the calcium, because you can see the phosphate doesn't actually change at all between reactants and products. It stays the same ion. These ions are just swapping places and swapping partners. To begin with, we should try and pick an element that is straightforward. Now you could go for either the calcium or the potassium. I'm just going to go for the calcium first. So on this side we have 1 calcium. On the product side we have 3, which means I need to put a coefficient of 3 in front of this calcium chloride to balance it. So now I've got 3 calciums on either side. A convenient place to go next would be chlorine. So on this side, I have 2 times 3, or 6 chlorine atoms, whereas on this side, on the products, I only have 1. Therefore, I need to put a coefficient of 6 in front of the KCl to balance out the chlorine. Now we can go to, say, the potassium. And you see I'm kind of just leapfrogging all over the place. It can be easier to work out chemical equation balancing if you use that kind of strategy. Anyways, potassium. On this side, the reactant side, I have 3, K3. On this side, I have 6 KCl, so I have 6. This tells me I need to put a coefficient of 2 in front of the potassium phosphate to balance that out. So 3 CaCl2 plus 2 K3PO4 becomes calcium phosphate. Now let's take a look. 6 potassium, 6 potassium. So let's check the phosphates because we're treating those as one unit. I've got 1, 2 because I've got 2 potassium phosphates. And look at that, I've got 2. These are balanced. Well, this means we can start going back and double checking all of the other elements to see if they're correctly balanced. Let's do that. How about calcium? 1, 2, 3, and 1, 2, 3. How about the chlorine? There's 6, 2 times 3, 6 on this side, 6, and 6. And lastly, the potassium. We've got 6 in the reactants because 2 times 3. And we've got 6 on this side as well. This is our balanced equation. We have all of our coefficients in place. Now we just need to rewrite it, including the indicators of state we figured out at the top of the page. So our final balanced equation is 3 calcium chloride aqueous plus 2 potassium phosphate aqueous becomes 1 calcium phosphate solid plus 6 potassium chloride aqueous. And that is how you balance an equation with indicators of state.